So what we have is now 133 over x cubed minus 8x squared plus 15x. That's a cubed. A little bit hard to see. I see that. So, same stuff. We want the bottom not to equal to 0. So x cubed minus 8x squared plus 15x cannot be 0. So we know that we could common factor out an x. X squared minus 8x plus 15 cannot be 0. We'll factor this one. This would be minus 3 and minus 5. And we get x is not equal to 0. X minus 3 is not equal to 0. X minus 5 is not equal to 0. And this is 3 and this is 5. And summarizing, we're going to say that x cannot be 0 or 3 or 5. So we have a list of 3 things that x cannot be. So we have 17 over 2 times x minus 4 times x plus 1. As usual, the bottom cannot be 0. So 2 times x minus 4 times x plus 1 cannot be 0. So we know that x minus 4 is not equal to 0. X plus 1 is not equal to 0. X cannot be 4. X cannot be negative 1. Now you may be thinking, what about this? Technically, we also know that 2 is not allowed to be equal to 0, but 2 is never equal to 0, so the 2 doesn't actually do anything. The 2 is just there. It doesn't actually cause a restriction in its own. And so the restrictions are just minus 1 and 4. X cannot be equal to those two. Okay, now this one, before we do the restrictions, we're going to try to simplify this thing. And if we're going to simplify this thing, what we're going to do is we're going to say, okay, I'm going to use purple for the simplifying parts. So we know that 20 divided by 4 is 5. And x squared over x cubed is x to the minus 1, or having an x on the bottom. Either way, it comes out to something like this. We have the 5, we have the y, and x squared over x cubed is x on the bottom. Now the restrictions are just that the bottom cannot be equal to 0. So if the y is 0, that's not an issue. So all we know, the only restriction here is going to be x is not equal to 0. Because if x is 0, then that's the bottom. And these are equivalent expressions. So that is equivalent to this one over here. So we are going to find the equivalent expressions first. The purple was a bit too tiny. Let's do a different color. We'll do the blue for the equivalent. So with the numbers, 4 over 8 is the same thing as 1 over 2. X to the 13 over x to the 8 is just x to the 5. Y squared, nothing else, is just y squared. Z over z to the 4 is going to be z cubed. So another way of writing this would be x to the 5 y squared over 2z cubed. So this simplifies to this. There are some restrictions, and the restrictions are just simply that this cannot be equal to 0. But no restrictions on the other ones. I was wrong though. So what was I wrong about here? I actually missed a very important part of this entire situation. What's wrong here is that that's not the only restriction, because these are not when we look at restrictions, we actually have to look at every step along the way. If there was a restriction at any point, then there's a restriction. So if we look over here, there's actually still a restriction. So when back on the first step, we saw that z cannot be 0, but also, in this case, x cannot be 0 and z cannot be 0. And so overall, our restrictions are this is equal to this, assuming that z is not equal to 0 and x is not equal to 0. Both restrictions are necessary. So that was a critical thing to overlook. So let's say we go through this one over here. We're going to simplify this. 15 over 10 is the same thing as 3 over 2. X squared over x squared, that's gone. Y cubed over y squared is y. Z over nothing is z. So this is going to be 3yz over 2. Now, if we look at the last step, there's no restrictions. But from here, there were restrictions. So in the initial situation, we're saying that this equals this, but there are some restrictions. And the restrictions are on this step, that x cannot be 0, and that y cannot be 0. So this is the same as that, assuming that those two situations are true.